Please welcome Platinum sponsor Dawn Patrick with Cherry Bekaert.
Morning, everyone. Wow, what a great start. So I'm Dawn Patrick with Cherry Bekaert. We are CPAs and advisors who focus on serving innovative companies, and it is our privilege to continue to support TAG, the GTS, and the Top 40 Innovators program. So I can't see you all very well, but I'm gonna ask a question, see if everybody's awake. So how many of you in the room have eaten something in the last 24 hours? Okay, come on, that should have been everyone's hands. So how many of those who have eaten something believe that what they ate came from agriculture? Oh my gosh, I don't think anyone raised their hand. So we saw music earlier, now we're gonna talk a bit about food. So I'm here and proud to introduce our next speaker, Caleb Harper, Principal Investigator and Director of the Open Agriculture Initiative at MIT. Many people say they want to impact the world. Caleb is actually doing it by changing how we grow food to feed and nourish the 9 billion people of 2050. An engineer turned urban farmer, Caleb is working to reverse the global food crisis by revolutionizing agriculture as we know it. At MIT, he leads a diverse team of engineers, architects, urbanists, economists, and plant scientists in the exploration and development of future food systems. Together, they're innovating what Caleb dubs the food computer, a disruptive, open source, scalable, controlled environment agriculture technology platform. Say that fast. The technology exists now, it's rapidly evolving and quickly finding support. Please welcome Caleb Harper.
I'm going to start with sharing a moment with you that happened to me yesterday. I woke up and my Twitter was exploding, and I had messages from CNBC, BBC, MSNBC, BuzzFeed, all requesting access to a video that I put online. So I was really worried about what accidentally I might have put online. And I happened to be at an event with Jeff Bezos, his team from Amazon, and I'll show you the video that I put up. Let's see if we can get that going.
Why am I feeling so much like Sigourney Weaver?
So this is Jeff Bezos inside of an exoskeletal robot that was recently walking around. It has very little to do with my talk, but I had to upstage Shimon. So we'll go forward. If you don't know about the Media Lab is a weird place on MIT campus. In fact, the founder of it called us the home of the intellectually promiscuous. Our current director calls us the anti-disciplinary, and I think MIT believes we have no discipline. But inside there are 30 research groups, and we're as broad as synthetic neurobiology, biomechatronics, new cars, new toys. The only thing that unites us all is a suspension for disbelief of anything, and that we have the passion, instead of publish or perish, to demo or die. So that takes us to projects like this, Hugh Hare's lab. Hugh lost his legs as a mountain climber when he was somewhere in his late teens, and he's gone forward for the last about 30 years, building and rebuilding his own legs. The newest things coming out of Hugh's labs are the connections between the neural interface, your brain, and his legs, so being able to process signals through by thinking. Another group started with something more imaginary and said, we're gonna do teleportation. And lots of us in the room are nerds, so we all want to do teleportation, but we had to actually build it if we were going to talk about it. So this is a project out of Hiroshi Ishii's lab. If you remember that game where you put your hand into a set of pins and it comes out on the other side, this is computer vision, machine learning, and allowing you to play with that ball anywhere else in the world. So then it gets me to my work, and you might wonder why I'm standing on stage at a technology conference with an apple. But an apple is pretty amazing technology, so I'll take a quick vote. All right, I saw you guys didn't really vote earlier, but I'm gonna get you to vote. How old do you think the average apple is from the date it was picked till the date you put it in your mouth in a United States grocery store? Think about it. All right? 0 to 1 month. There are some optimists. I'm an optimist. I love you guys. 1 month to 3 months, about a third. 3 months to 6 months, 6 months to 9 months, 9 months to 12 months. None of you saw my TED Talk. That's awesome. Okay, so it's 14 months. 14 months is the age of an apple, average age of an apple in a grocery store in the United States. One of my biggest sponsors is a retail company, and retail food company. And you would wonder how an apple that could ostensibly be the age of a toddler and talk to you could wind up in your mouth. And we built a very, very big system, and it was pretty amazing for feeding a lot of people. But this apple at 14 months has 90% less antioxidants than it once had to give you. It's basically a ball of sugar and cellulose fiber. So the point of this is to say our system is amazing that it's big, but it's starting to fail us locally, so it's going to become more discretized. This is a study of the USDA, and I'm pretty sure they're sad they shared it with me. But if you look down this thing, this is what people would support or oppose in government policy related to food. Many of the items are very contentious. The only one that everyone overwhelmingly agrees on is mandatory labeling of food containing DNA. Anyone? No one's laughing? You're the, okay. All food that was once alive contains DNA. I know it's a technology summit, but 80% of the American population would support mandatory labeling on food containing DNA. So this is not modified DNA, this is not GMO, this is not all of those things. It's to say right next to gluten-free, organic, whatever it is you want to get marketed to, it's going to now say contains DNA. So we are dealing with a genuine ignorance when it comes to what we're eating, and we need to fix that. So the two biggest problems in food, too much centralization, going to start to localize, and not enough information or transparency getting down to most people. We're going to change that. So agricultural revolution has always radically changed society. It's the reason we're in this room, the first agricultural revolution, domesticating plants, the birth of civilization, the only reason we're here today. The second one, the beginning of technology-based societies, which we're all living a part of, the horse and the plow, and then on until we could move off the farm and start to live a different type of life. The third revolution is the reason we have cities today, and that's green revolution, vertical integration of farming, biotechnology. Anything happening, CRISPR, gene editing, is still biotechnology and still very much in that third revolution. So the question for my group is, what's going to be a part of the fourth revolution, and how is it going to radically change society? This is literally what got me a lab at MIT. Just wait. So first I told them that I believed in the future we were going to have climate democracy. And what I mean is, this is a map of all of the most beneficial climates of agriculture in the world. The most in green, the least in red. This is why Californian farmers are now Mexican farmers. This is why China is now the largest landholder in Brazil. We are slave to climate. And I believe in the future we're going to start docking it. You're going to see systems where we design the climate that we want. Why can't Africa have Napa? Why can't India have Bordeaux? The next question, any chance to use Willy Wonka? If you remember this scene where he zaps the candy bar and he sends it through the air on the other side, and then he reconstitutes it. I believe we've reached this point in our lives now when something like Pokemon Go, it's a game, you hold up your camera to and you catch an imaginary creature. And in this action, in 1 week, Pokemon Go had more users than Twitter and Tinder combined and became a billion-dollar company, just by the amount of data that they harvested off of your wrist, GPS, accelerometer, so on and so on. Have we not reached the point in this data-driven world that we can start to affect things like food systems in this way? The last one, when people say there's this many more billion people by this many year all the time, I'm always wondering, what are those 2, 3, 4 more billion people doing? So the average age of a farmer in the United States is 58. 2% of the population is directly involved in agriculture. I'm the son of an agricultural family, of a family of immigrants that came to the United States. I don't do, well, I do now, but I didn't do agriculture because they said, get off the farm, go do technology. It's not just in the United States. Japan, when I landed at Fukushima, that was the headline. Japan has no money, no youth, no land, and no future. The land was salt contaminated, radiation contaminated. The youth had left for Sendai and Tokyo, and they were already importing 80% of their own food. On down. Half of the population in Africa, under 18, 80% don't want to be farmers. They're leaving the farm in droves. They've seen their families have a hard life. They're moving into the city. Last one, in India, more farmer suicides in the last 3 years than in the previous 10. The world is about to experience a knowledge gap in farming that it has never seen before. So the question is, can we create a new generation of farmers? Can they be data scientist farmers, algorithms farmers, mechanical engineering farmers? We need to create a movement. We've seen these movements, at least I saw the very beginning of the very end of the coder movement. The maker movement, I guess we're in or maybe over with soon. The network movement, where all these, the network potential of collaborating with millions of people. We're now entering kind of a food movement. And I can say this squarely because in the Media Lab, a place never known for biology at all, used to be called the Digital Media Lab before we dropped digital. There are now 6 labs out of 30 doing biology. And so the convergence of biologic systems and man-made digital systems is producing new sets of tools that we can inspire a lot of change. So these are some of the tools that I've been working on, which I call tools for climate democracy. So this was about 6 years ago in my lab, and we were just having a lot of fun. And there's a lot of fun technology in here, but I think the most important part is once a month we had a harvest. Bright white roots, deep green colors in the middle of the Media Lab. Is this a new restaurant? Is this a new potential for a corporate cafeteria, school cafeteria? I know one thing for sure. This was the first time anyone in the lab ever ripped the roots off of anything. We get our salad in bags in Boston. And so this was a catalytic moment that got me a whole bunch of people to help, roboticists, data scientists, start producing the next generation of agriculture. So we had a moment where we would take that food out and we'd give it to people, and then we had a little bit left over. And when you grow it, you're proud. You know, you're like, this is my food. And the next day, anything that was left would taste incredibly sweet. So I got really mad at my students. I thought they were messing with me. I put up cameras. I created a police state in my lab. And I realized something very old. Plants under stress produce biochemical difference. So this plant was experiencing a drought state. That drought state caused it to express different biochemicals. Those biochemicals tasted sweeter to me. So I learned in that day that I could produce, if I could code climate, I could code flavor and nutrition. So then we thought of building a lab that could go anywhere in the world because we knew it was a ton of variables that we had to share with everyone. So we sent, on the facade of the Media Lab, we had a lab. We've now taken it down, but it had 30 points of network sensing per plant. If you know about the genome or genetics, I'm talking about the phenome or the phenomena that surrounds genetics. If I had an identical twin and he ate a little differently and maybe exercised more, he would certainly look different and may taste different too. So that's what we're doing. We're designing climates to produce flavor and nutrition in plants. That blue line that you see going across, that's what we call our digital climate recipe. Imagine that's 1982 Napa, and we're trying to recreate the perfect Cabernet. All the wiggly lines are all the sensors that we're all dealing with now. We're trying to get that noise closer to the line. All of that data that we collect gets correlated to an individual page about that plant. So you can see things like new leaf added today. That's because we're running computer vision that's watching that plant, or notifications and timelines. Most importantly, we're trending against all the other data on the left-hand side, which is all the other plants in the lab that day. So we're learning about phenomenological relationships that agriculture's never been able to study with this amount of data. So this is what the lab looks like now. I'm actually an architect and a structural engineer, so I used to design data centers for HP and hospitals in the UK. So I've put this control environment design theory to work here. And we've started doing all kinds of things. On the water management front, people like to focus on a system called aeroponics. NASA developed it for Mir Space Station because shipping water into space is very heavy, so they wanted to use a lot less. So what this system does, which we've adapted here on Earth, uses 90% less water by hydroatomizing it at about 10 to 50 micron, no standing soil, and you're gonna end up growing plants with this system anywhere to 3 to 5 times faster. So this is just if you're, getting a little tired of the ponics, like hydroponic, aquaponic, aeroponic, blah, blah, blah. It's just sub-irrigation systems where we're using water much more efficiently than we have before. So this was trials with General Mills and Driscoll's on strawberries. This was one of my favorite ones. We made a partnership with a rare and ancient seed bank. If you don't know, there's about 4 cultivars of tomatoes that you've gotten to eat in your lifetime. There are tens of thousands of cultivar tomatoes in the world. We got from an ancient heirloom rare seed bank that hadn't been grown in 150 years commercially. We basically brought them back to life, grew them. They were supposed to be the best sauce tomatoes in the world. Unfortunately, none of us cooked, so we ate them raw, and they tasted mealy and gross. But the point is, we have a genetic diversity that is completely untapped. We have selected, not for taste, not for nutrition, but for shippability, which made sense at the time. There's only been one GMO ever for flavor saver tomato went away, and only one for nutritional value, which is golden rice, which is happening right now. So we have an amazing collection that we have yet to search. I'm also doing cotton. I wouldn't have thought I would do that. It's a commodity. It's kind of insane. But I learned from one of my sponsors. It's the world's largest cotton supplier for sheets and towels to the United States, that cotton was experiencing a lot of trouble. It's a very thirsty crop. Yields are going down and flatlining at least. And in India, where they are, the water table is dropping feet per year. I said, okay, well, if I'm going to grow cotton, I'm only going to grow the best cotton. And I said, where's the best cotton? And they said, Iceland. And I was like, okay, you got me here. Like, okay, Iceland. So turns out the very, very best quality cotton in the world is called Icelandic cotton. It's a variety that evolved over time for a very specific microclimate, and it produces like 44 mm fibers. The regular fibers are somewhere around 32 mm. So our project together is about literally creating Iceland in India and creating a factory that goes from growing to ginning to spinning to milling to product making to out the other side. This fundamentally changes the economics of agriculture when it's 365 days consistent with known inputs, known outputs, and known quality. So then we started growing human beings, and at MIT, they all come out looking like this. No, I knew that my systems were too expensive. The capital costs alone were killing me to keep producing more of what I wanted in my lab, which was instances. So I needed more instances to do single variable isolation of all of these massive data sets. So we started building tiny ones, at the time calling them Growbots, and then we released this thing called the personal food computer. It was pretty simple at the time. You could still build it if you want. It's made out of parts mostly from Home Depot and Amazon, but it's run on Raspberry Pi and Arduino, microcontroller that kids know these days. And it's coded up in Python, which any of you coders know is pretty easy to play with. So then we gave them a game that we built in Unity. You could log into their bot anywhere in the world. They had a digital environment, a physical sensors, and actuators. So then they loaded a recipe that any other kid had grown, and they began the sequence by planting a seed. But they got curious as the climate was getting created. They said, well, why does the plant need CO2? Crank down CO2, plant dies, kid learns a lesson. But as they go in and they virtually harvest the plant, and they physically harvest the plant, it comes with a derivative recipe. They've now become a part of mapping the phenome of that crop. Then they can download all of the data, share it with everyone. We've had a lot of great Google Science Fair winners coming off of this lately. That's 3 weeks grow time in a food computer, so it doesn't suck for a kid that normally plant growing is pretty boring. We put this in all different ages. In this group, so I had these little kids, and I was trying to keep their attention. And so they were learning to measure. That's all they were learning, tactile ability with their fingers. And so they were measuring the plants, and the data off the plants was being taken forward by the 8th graders who were learning to draw lines. But learning to measure is pretty boring. So then I showed them blow into the food computer, and they blew in and watched the CO2 rise, and they were just ensconced by this. So then they all lined up, all started, and it was so not sanitary what was happening. But by the end of it, they had more CO2 in there than it was equivalent to about 10,500 feet above sea level. And so that was pretty fun. I was super surprised by what came next. One of my teachers took Farmer's Almanac data from 1950 in Massachusetts and programmed the climate of the past. Then they took current climate data and programmed the climate of the present. They followed that up by using data generated by IBM Watson to produce the climate of the future in their area. When you talk about changing climates and you tell that to a kid and they look up and they say, I don't know, looks okay, or I don't know, I can't do anything about that. Putting a climate in their classroom, 365 days a year to experiment with, see what grows, change things. I mean, I went into the classroom, I said, set it to 65% humidity. This was an 8th grader. And he said, what's humidity? And I was like, you're an 8th grader, okay. It's water and air. And he says, there's no water and air, you're an idiot. And I was like, oh my God, this is my parents' prophecy, come back. This is me, this is me. All right, kid, set it to 100. He sets it to 100, it starts to condense and fog and drip. And he says, oh, humidity is rain. Why didn't you just tell me that? So, talk about STEM learning and getting them engaged. I think we're looking at platforms like this. So we released this about a month ago at the White House at the Maker Faire. It went kind of crazy. This is the next generation of it, which is a bit more like a Ferrari than the previous one. And then our first deployment actually came in Jordan. And I was surprised by this as well, with the UN and the World Food Program. So we just put these last week in a Syrian refugee camp in Amman, Jordan. And you might think, oh my gosh, what a disaster. You put this crazy technology in a refugee camp that can't support it. And that's what I thought. I was really worried. So I was really honest, and I said, this isn't going to feed them. And they said, do you know that most of the refugee camps are on 100% maritime food relief for anywhere between 20 and 40 years? And do you know that the international aid budget is getting smaller because our domestic spending is getting bigger? So we need to start produce any capacity for these people to grow things inside of their own camps, and what they really need is to be connected to other growers to share knowledge. So super proud that that's happening. My team has gotten too big. We're a bunch of weird farmers. So showing for one of the first times our new lab that we're building right now. MIT has a particle accelerator that's been shut down. When CERN turned theirs on, we turned ours off and we tried to sell it. Apparently no one buys old particle accelerators, so I have now inherited a new lab with 10 megawatts of power, a 10 gig Ethernet connection, and an on-site data center to become kind of the nervous system for our burgeoning community. So I want to talk a little bit about data and what we're doing with that. So of course we're collecting things like ambient environmental data every 8 seconds, or you can throttle it up and down, frankly, as much as you want. This is all open source to everyone in the audience. It's free to build it, or give it to your 12-year-old. They'll knock it out in a couple days. So temperature, humidity, light, spectrum, all of this good stuff that can be collected non-invasively all the time. But we take it further. People say, but what about the terroir? You have no soul. My family's in farming, and I've had dirt on my boots, but terroir is minerals, oxygen, carbon, and microbiology. So we unpack that with a tool called spectrophotometer that we use to study all of the minerals, micronutrients that are in the water. We have taken the plants forward. What you're looking at here is culturing and sequencing of that basil. So the bottom Petri dishes, we just literally took a sample, cultured it out, sequenced it. As it goes to the top, you'll notice there's not much there. It's because the leaf surface is basically sterile. So just like human beings, most of the action is happening in the gut, right? We have trillions of bacteria here that some say are making the decisions for the big unit. Same thing going on with the plant. All the activity is really happening in the root microbiome. We were the first people to culture and sequence an aquatic root microbiome, which we thought was weird. But then we found out it's because the price of sequencing has become so cheap, it's never been there before. So we were able to send it out for a couple $100s and get it done. Now we're comparing that against the soil microbiome and saying, what's in soil, what's in the water culture, what's in the plant biome, and how would we design the microbiome to be more effective for humans? We also do a lot of computer vision, machine learning, so what you're looking at is just implementing a lot of what are now open source computer vision models, but getting as much information as we can, things like edge detection models, going forward and collecting morphologies about the plant, color differential about the plant. We use things like spectroscopy. So a lot of people are into spectroscopy right now, which is the ability to take a picture of something and get back this, well, not that reading, but a big reading that says this is how many colors and of what intensity you're seeing. So there's companies like Scio that are saying this, now you can scan your food. And for those of us that know, there's 15 kinds of fish that can be called sea bass. You're probably not eating a sea bass. So if you were to scan it and get a spectral image, you ostensibly would know what the truth was. But the reality is the technology is happening before the data sets are happening. So we're getting a lot of spectrometer and spectroscopy images, but we don't have the corollary data set that says, what does it mean? How good is it? So that's part of what we're building. To know how good we've done, other than my tongue, which now can taste pH within 0.1, because I do this every day, We take the plants forward and we do gas chromatography and mass spec. This means we take the plant tissue, we liquid nitrogen freeze it, we grind it up, and we send it through for analysis, and it comes down to the compound level. Now, what you're looking at may seem weird, and you're like, I don't eat biochemicals. But yes, you do. Biochemicals, these secondary metabolites, are what make flavor in your mouth. Secondary metabolites don't matter to the plant. The plant cares about primary ones so that it can live and do well. Secondary ones are everything we care about, so that's flavor and nutrition. So we study that so that we might eventually create models that go down to the individual chemical layer to get you better nutrition. That all makes about 3.5 million data points per plant per grow that formulate into a recipe. So for you roboticists out there, we have created what I could call the world's slowest robot, which is our farms. And it's all programmed in ROS, Robot Operating System, to engage that community to come along on the ride with us. So we put that recipe into the robot, it plans, actuates, creates environments, senses, and does it all over again. That data that we take going forward helps us to create new models. There's never been a model of biology and agriculture that's based on real-time data feeds. So we're taking that forward, hooking it up into the VR, AR environment system to create simulations so that we can understand the mathematics of plants a bit better. We also take all of that data forward in machine learning. So what you're looking at here is some optimization and Gaussian process regression models of our data. You know, I've been talking about a ton of different variables, and you're like, how in the world would you study all of these? Well, this is how you have to do it. This is a human-readable version of what we're doing, but if you look for it, look at the hot spots. So we've asked the machine, just like Willy Wonka did, where's the next candy bar gonna come from? And then the machine said, I don't wanna talk to you. We got a similar answer once. We put it in and we said, optimize for biomass. See the red right there is telling us what combination of variables the machine learning thinks is associated with biomass. And then its return to me was turn off the lights. So it wanted me to turn off the lights in our environment, which would obviously kill all of the plants. And so what you learn about AI and machine learning as you get deeper is it only matters if you have super quality, well-organized data. And if you don't, it's gonna give you answers that any 3-year-old could give you. And that's what was happening. But we've gotten a little bit smarter, and we partnered with a company called Sentient. We've had 3 trials now that show it's absolutely possible for the machine to do a lot of the work for us. So we create these new models, and then we wonder, are they any good? And so what one of my postdocs did is they scraped all the weather data from the EPW weather database, which is 30 years of micro weather station data spread across the world in all those places that you see. We took that weather data and we turned it into recipes like we use. And then we fed it through our models. And we said, where would the best quality cotton in the world be grown given the weather of the past 30 years? And then we correlated it against the FAO index for cotton from historically, from 2010, 2012, 2014. And by doing that, we were about 75% accurate as to where the best quality and most yields of cotton were in those years, and now we can predict where it will be going forward. So it's not just what's grown in control, it's also what we learn about plants that can be taken into the real world. A lot of companies right now working on this left-hand side, right? So microsatellites, satellites, drones, soil sensing, whatever. I mean, if you want to look at a new company in that space that's killing it, look up Farmers Business Network. They have more in-field data than the USDA has as an entire history, and Farmers Business Network is 3 years old. So lots of data coming on that side. The missing data is on the other side, which says if you have this world that you now know, what should you plant in it? What specific genetics, what specific crop would give you better protein, better flavor? Maybe the corn belt shouldn't be the corn belt. It should be arranged by microclimate. Maybe we shouldn't look at technology and seed for an adverse world only. We should look at the world as a catalog of technologies to deploy the seed technology that's been brewing for the last 100,000 years of evolution. About this time, you're thinking that's me. You're thinking that it's only in space. Sorry. And so I want to show you that, yes, you're absolutely right. This is aboard the International Space Station right now. They're doing these growing experiments. But if you haven't seen it, this technology has landed on Earth. This is in Japan. There are 900 hectares of what they call plant factory. Worst marketing term in the history of the world. But this factory produces 1 million heads of lettuce every week, 365 days a year. You might think, I would never eat anything grown in a clean room because that's freaky. It's selling branded Toshiba. This is lettuce, and it's selling for 3 times the premium. Why? Because they have genuine fear of their food. Their food has killed babies. Their food has made people very sick. 1/5 of the farmland in China is polluted now. That's why they're going other places. So if they're going to grow in country, the people are demanding provenance. And I think we're on our way there too, with the rise of organic, and eventually what I predict in the next few years will be the death of organic and replaced by something more articulate. So it's not just plants, it's also animals. If you're interested in this stuff, the rise of cellular agriculture is happening right now. So lab-grown meat and all of that stuff, I know these people. It's not fake. It's very real. But this one is a little bit stepped back. It's already happening in Munich in a warehouse in the dead of winter. I walked into this warehouse, and it felt like a mangrove forest. It was producing prawn 365 days a year, blue prawn. I was with three Michelin star chefs. We were all equally freaked out because we were like, why is the prawn blue? What did you do to it? Turns out the tanks were blue. The prawn have a natural ability to camouflage to their tanks. And so what you're seeing is the interaction between a very complex biological system and a man-made system creating something different. Across the board, the 3 Michelin star chefs said this was the best prawn they'd ever tasted in their life. So this factory looks kind of like things that I've shown you before, but it's very, very different. Imagine what it's growing. Lettuce, basil, stuff that everybody's seeing. No. It's actually growing tobacco. That tobacco has been infected with a tobacco mosaic virus. That virus is present with the plant in a very specific environment, which causes an expression of a protein that's Ebola resistant. So what you just looked at was a DARPA project of manufacturing Ebola vaccine. So we're not just talking about lettuce, which I predict is probably not the best use of the technology. We're talking about pharmaceutical natural derivatives that we used to run around the Amazon trying to collect and then make synthetic. We're talking about nutraceutical, and we're talking about cosmetic natural derivatives first before we get even into the edibles. And so reality hits. This is where we are in the state of our industry. Think of it like cars before Ford. Cars that were pedal-powered with a sail attached, that were very weird, that killed people, that had no standards. This is where our state is, and it's because everyone's drawing a very tight little black box around their technology that ostensibly is thousands of years old. And so by not having standards, by not sharing data, we are really limiting and slowing this and having giant failures because the capital equipment cost alone is, in most cases, tens of millions of dollars. So I'm taking a cue from industry. I'm saying, all right, Musk, why did you open source the patents of Tesla? And you know what his answer is? Not because he doesn't like money. His answer is because he needs charging stations for his cars. He's not going to be able to provide all the infrastructure, all the charging stations, all the things that's necessary for his cars to become successful. So he's hitting the network by making that knowledge open. Apple, the most proprietary company of all time, now taking its Apple app developer language open to hit that network economy. Facebook, arguably their hottest asset right now, TorchNet, their AI, completely open source. Why? Because they need so much input from all of you. All that data I talked about, the only big data sets we have are like from Twitter, and how valuable can those really be? So we need to start creating new data sets. We need new thinkers in AI, so everything becomes open source. And a great example of that is the last one, human genome. Without open source knowledge sharing, without 10,000 researchers and a bunch of money and a bunch of different places, we would have never mapped the human genome and taken it from like $3 million 5 years ago to $1,000 today. We're violating Moore's law by making things open source and hitting the network. So this brings me to the last point, and that's my community. So the fundamental reason I started going open source is I was sitting in my lab, and I used to bring people in all the time. And then TLO came in, Technology Licensing Office, said, don't do that. You have IP. You're sitting on golden eggs. And I said, well, that's awful, because I just want to bring people in, so what's the opposite? They said, well, you could give it all away for free, so that's what we've done. When we did that, the first thing we put out was the personal food computer, that very first one I showed you. And we just gave out videos, bill of materials, code to run it, how much it cost. And then maybe within a month, and then of course put it out on Wikipedia. So if you're feeling so energized, please join the revolution. Then a community sprang up in about a month. And this was, I don't know, is now about 1,000 people, bunch of weirdos, but a bunch of my favorite weirdos. We call ourselves the Nerd Farmers. These are students, scientists, makers, teachers, hackers, homebodies. These are the breadth of our society coming together and ask questions. The best thing it's done is get things out of my email inbox. Like people telling me about their attempts to build things, asking me questions. But more than that, it's started to spawn a global collaboration. And it's also kicked off something that we call, if you remember in the 70s, computer clubs, homebrew computer clubs, and they're making weird machines in their garages, sharing limited amounts of knowledge, but sharing it pretty openly. We now have food computer clubs all around the United States. These students have come into the Media Lab, this was through National Geographic, learned how to build a food computer in 2 days and taken it home and set up a chapter. But it's not just the United States. In the last year, we've had machines built in 20 countries on 6 continents. The only language we have in common is code. These machines are expensive and complex to build. Yet, this is the distribution that happened completely on its own. So imagine each of these and the subsequent ones that are now coming online as little cores of data processing. We basically have a multi-core computer so that we can distributedly go through all the variables of the things that people are interested in. I don't even tell people what to grow. They're just curious. They say, oh, well, I live in Africa. I want to grow a moringa tree. And I'm like, I don't know anything about a moringa tree, and pretty sure I don't know anybody that does either, but go for it. And they start growing a moringa tree, and immediately someone in India is like, oh my gosh, I could grow a moringa tree? I want to taste a moringa. And it just goes on like that, forward. So I'll close down with this. This is the world as it is right now, and it's the product of 3 industrial revolutions. Any country with a color at all, start with the red as the base layer, is considered food insecure by the FAO, which means it doesn't produce enough food inside of its national boundary to feed its domestic population. Any country that's also red and purple is a country that's food insecure, but producing food for other countries and sending it out. Mexico and us, for example. Over the top of that are all of the logistics distribution lines. So this is how your average grape takes 5,000 miles to get to you. This is why that apple has to be 14 months old, because they hedge it for a global market, just like oil. Now, this is actually an amazing thing. This feeds billions of people. This has spawned so much life. I am so respectful of the green revolution, of synthetic nitrogen, all the things farmers have been doing. But I think you see where this begins to fail when it gets a bit too big like it is now. So this is the world I imagine. We replace those distribution lines with data. We're able to say, I grew this tomato in Boston. Now this tomato can literally be emailed anywhere else in the world, can be iteratively searched for the characteristics you like in a tomato, whether you like a nutty tomato or you like a whatever it is that you're looking for. And that becomes a farmer's mind in the cloud that never dies for everyone to use going forward. So the future of food is not about arguing about what's wrong with this. It's not about camping off and saying anti-GMO, GMO's saving the world, organic is the right way, organic is totally marketing BS. This is what's happening right now. Just stop. The future of food is about creating a platform with open tools to share open knowledge, to empower 1 billion new farmers to simply ask and answer the question, what if? Thank you.